Hello everyone, today we are going to learn 8.2, the inverse of Laplace transform. Okay, so we had last time Laplace transform, which is uh, we using the script of L and then L of f of t. And we are using the Laplace transform. So we are using uppercase of S. So in terms of we have to convert everything from T to S, right? So that we using the formula integral of 0 to positive infinity e to the negative st f of t dt, right? Okay, so we did that last time, 8.1. Today we do inverse Laplace transform. So backwards, yeah? So for example, if we have answer like 1 over s squared minus a, then we inverse of Laplace transform is like we have f over t. We need to find that f over t. Make sense? So it was 1, or it was t, or it was sine omega t, or cosine omega t, right? Okay, let's do that here. So example 1, use the table of Laplace transform to find inverse. Okay, so 1 over s squared minus 1. Okay, now let's take a look this one. We have b over s squared minus b squared. So we notice that b equal to 1 in that case, right? Can you see? Can you read? Too tiny, huh? Okay, let me make a little bit bigger. Yeah. Now you can see, well. All right, so in that case, b equal to 1. Then if we have this form, inverse, then we get hyperbolic of sine bt. B in that case is 1. Yeah? So there will be sine, hyperbolic of sine bt, which is hyperbolic of sine, b is the 1 and t. Yeah? Okay, now second one. We have inverse Laplace transform. We have s over s squared plus 9. And I brought this one. I cannot see the other one. All right. Then in that case, what is omega? Omega equal to 3, right? So let me make omega equal to 3. So omega squared equal to 9. Yeah? Okay, then cosine omega t. We did this one before, right? Yeah, so that will be cosine omega, which is 3t. That is the answer. Make sense? So we understand what we are doing right now, right? So inverse Laplace transform. So previously, we were finding this one, right? By given this one. Yeah. And now we're using this one, inverse, and we need to answer this one. Clear? Okay, very good. All right, so we have a theorem, linearity property, right? So we have f sub 1, f sub 2, until f sub n are Laplace transforms. And C sub 1, C sub 2, and C sub n are constant. Then we have inverse form, C sub 1 times F sub 1 plus C sub 2, F sub 2 plus until C sub n, F sub n. Then we have C sub 1 and inverse of the Laplace form, right? Okay, so we might think that constant, we can take it out. Can you see that? All the constant term here, right? Okay, so let us do this one. All right. This example, find the inverse of Laplace transform, right? Okay, so we have inside addition, we can split the term. Can you see that? Okay, now we can take out the constant term, right? Make sense? Okay, now let's do that. Make it bigger so you can read. All right, so there will be 8 inverse of Laplace and 1 over, oops, S. In that case, it's a 5. Yeah. So let me write it as like that because we might get confused with the 5. Yeah. Plus, and then we take out the constant term outside. So we have a 7 and inverse Laplace 1 over S squared plus 3. Yeah. Okay. What can you see? We can see that in the case, log 1 over S minus A. So there will be S minus -5, right? So let me write down note. S minus -5. So A equal to -5 then. Can you see? Okay. In that case, ooh. So we have omega squared. Yeah. So what number we can make 3 from the square? Yeah, right. Square root to 3, right? Okay, so omega, which is 3. So, sorry, square root to 3. So omega square, which is square root of 3 squared, we get 3, right? Okay, the problem. So we have 1 here, and then they say the omega there, right? Okay, how do you do? So it's like we multiplying by 1. Omega, in that case, is square root of 3. What is the 1? So we multiply by 1. So square root of 3 and square root of 3 there. Make sense to you? So we're going to do that. So square root of 3, square root of 3. Yeah, that's multiplying by 1. So technically we did something. Literally we did not do anything because it's times 1. Make sense? Okay, now the inverse of Laplace transform is e to the at. A in that case is -5, but we have a constant, we keep that constant. Make sense? So there will be 8 e to the at -5t plus, and we get this one sine omega t. Omega in that case is square root of 3. We keep their constant, so 7 over square root of 3. Yeah. So 7 over square root of 3 and sine omega t. Make sense? Okay, very good. All right. So I got this one from the table, Laplace table, like what we did the last time. Same table, so we have one here. Yeah. So this one we are talking about, right? So we had one, then we found Laplace transform 1 over s. This section is inverse. What if we have this? Then we need to find this one, f over t. That's the inverse of Laplace transform. Make sense? Okay, very good. All right, so let us do this one. Okay, we want to find inverse Laplace transform. All right, so I found this one very close to this inverse. Yeah, okay, now, but then we have to make this form, right? How do you do? Yeah, completing square, right? So make a completing square. So let us do this. For completing square. So we have a b over 2 square, right? B in that case is 2, ABC. So 2 over 2 square, which is 1 square, which is 1, right? Okay. Then let us make, we have from s square. Let me make a s like that, right? Because we have 5 here too, right? Plus 2s, and then plus 5. This is 5, this is s. Yeah. Okay. Now, we want to make a completing square. So that will be s squared plus 2s. And we add plus 1, right? And plus 5. Since we add 1, we subtract 1. So once again, technically we did something. Literally, we did not do anything because it's 0. Yeah? 1 minus 1 is 0. Clear? Okay, now we need to factor out, right? So that will be s plus 1 squared for this one. And then the rest is plus 4, right? Clear to you. Okay, now let us make this form then. Yeah. Okay. So I just want to copy 3s plus a4 numerator. So we have, let me writing out everything, make it clear. So s squared plus 2s plus 5 equal to inverse Laplace and 3s plus 8 over s plus 1 square plus 4. Yeah. Okay, now I want to express 3s plus 8. We're gonna learn this technique. We had experience before, previously. I mean, previous course, right? So inverse of 3s and plus 8. I want to express plus 3 plus 5. 5 Okay, so there will be over s plus 1 square plus 4. Okay, now I want to split 3 and 5. This one and by itself, okay? We can do that, right? Like earlier, right? So earlier, we have addition inside. This is already in there, okay? All right, so look, technique then. We have inverse Laplace 3s plus 3. Okay, let me write down here. Sorry, I want to make a organize plus 3 over s plus 1 square plus 4. And plus inverse 5 over s plus 1 square plus 4. Okay? All right. Now, in that case, we can factor out with the 3, right? So let me factor out the 3. I don't have to show the work, right? So s plus 1. Yeah, maybe I can write down here. Note 3. Three s plus 3 equal to 3s plus 1. Yeah. Okay, over s plus 1 square plus 4. And we can take out this one constant, right? So plus 5 inverse 1 over s plus 1 square plus 4. Yeah. Okay, now let's take a look. It was too early. Copy. Yeah, I have it here too. Okay, good. I have it here. All right. Okay, so which one we can use as omega? Which one? Yeah, one number for omega, right? Yeah. This one looks like a form of this one, right? Yeah. So lambda equal to, once again, s minus -1, right? So there will be s minus -1. So lambda will be -1. And omega, we notice that omega equal to 2. So omega square equal to 4, right? Okay, now 3 left to 1, which is e to the -1t cosine omega, which is 2t, plus. Okay, so in that case, omega equal to 2 as well, right? Okay, but then we have to have omega there, right? Which is 2, right? But then we cannot just writing out 2, so we multiply by 1, which is over 2, right? Make sense to you? In order to keep that format. So let's do that. Times 2 over 2, right? Okay, now we can writing 5 over 2 and e to the lambda. Lambda in that case also s minus 1. So lambda equal to -1. Yeah. Okay, so we have e to the negative lambda 1t and sine omega, which is 2t. That's the answer. Make sense? Very good. Okay. Let's do next one. So we want to find inverse Laplace transform of that. Okay. All right. How do you do? No idea, right? Okay. So we're gonna learn new technique. So we have 3s plus 2 over. Okay. Let's factor out. So s minus 2, s minus 1. Yeah, that's the factor out. S minus 2, s minus 1. Would you like to take a look the table? Which one is very close? Okay. Yeah. So s square something, right? Let me write down. Yeah. Look for anything close to. I don't see that. I don't see that. S squared minus 3s plus 2 over 3s plus 2. Yeah, inverse. Why don't you take a look? Yeah. Over here. Yeah, we don't see that any close to that one, right? Okay, how do you do that? Let's make a partial fraction decomposition, okay? So let's make a little bit simplify. All right, so partial fraction decomposition. Okay, now, so we will get s minus 2. And plus s minus 1. Yeah. And then we say the a plus b. Okay, make a common denominator. S minus 2, s minus 1, as minus 1 plus b, s minus 2, right? Okay, so that will be s minus 2, s minus 1, and distribute as minus a plus bs minus 2b, right? Okay, now ss. So let us make that this one corresponding 3s plus 2, right? So let me make here 3s plus 2 equal to, right? As minus plus bs minus a negative 2b, right? Okay, so there will be a plus b s minus a minus 2b, right? So we have a corresponding, right? So 3s corresponding with this constant with a constant, right? Okay, so there will be 3 equal to a plus b, 2 equal to negative a minus 2b, right? Okay, nice number. So a minus a, which is 0. So we have a b 1 minus 2, which is negative b, equal to 5, right? So b equal to negative 5, then what's the a will be? A plus b. So, oh, sorry. We have to conclude b, right? Yeah. So b equal to negative 5 then. Okay, since b equal to negative 5, then a equal to what? Negative 5. A equal to 8. No, wait a minute. Positive 8. Because if we add, there's a negative 13, right? It's a positive. Yeah. Okay. Now we almost done. Uh, we have a new form, right? So new form will be so I want to make the Laplace transform is A over S minus 2 and B over S minus 1, right? So that will be A was 8, B was negative 5, right? Okay, now let's find the inverse. So inverse of 8 over S minus 2 plus negative 5 over S minus 1. So we can use that 8, 1 over S minus 2 minus, okay, let's make a plus and negative 5, inverse missing, 1 over S minus 1, right? Okay. I have this one here. Yeah. 1 over S minus A. Okay, so what do you think? A indicates 2, right? A indicates 1, right? Okay, so we will use equal to e to the a 2t, and then we have a constant a, right? And minus 5 e to the at, a is the 1, and then t. Yeah. Make sense? Okay, that is the answer. I have other method here. Yeah. So if from the partial decomposition method, right? So if we have this one, and let's make a equal to 3s plus 1 from the original one. Yeah. And s minus 1. we don't substitute 2, right? So if we make a, I'm sorry, if we substitute 1 is undefined, so we substitute 2 in that case. So we got A, so A equal to 8. And if we have B equal to that, then we substitute 1. So basically, what's the 0 for this one, right? But we don't want to make it 0. We substitute opposite one, right? So S equal to 1, then we get the B equal to -5. That's other method to find A and B. And then we using the same process. Yeah. Okay. All right. So let me arrange the note later. We have a theorem. Suppose the f of s, then we have fraction p of s, which is p is a polynomial degree less than n, and over s minus s of 1 times s minus s of 2 times s minus s of n, and s of 1, s of 2, s of n are distinct. Yeah. Then we can express, looks like this is a partial decomposition method, right? Yeah. Okay, so let us do this one. All right. So we want to find inverse. This is the last one, okay? We want to find the Laplace transform inverse, yeah? Okay, so we have this form. All right, so this one, we can use that. Since we have a cube, so s plus 2 square, and s plus cube, right? So we are going to use that. Yeah. All right. So let us do this one. There will be A over s plus 2 plus B over s plus 2 quantity squared plus C over s plus 2 to the third power. Yeah. Make a common denominator. So there will be s plus 2 to the third power. Then in that case, we have A s plus 2 squared plus B s plus 2 plus C. Yeah. Okay, let's distribute, right? Note, this one will be s squared plus 2s plus 4. Yeah. Okay, let's do that. So there will be as squared plus 2as plus 4a. Yeah. Hold on 1 second. 2ab. So I made a mistake. 2ab, right? So 2ab. So it's a 4. So it's a 4. Yeah. Okay, now plus distribute. We have a bs plus 2b plus c, right? Over s plus 2 to the third power, okay? All right. Corresponding, yeah? S. Let's make that. S squared s squared, which is same as a s squared, then a equal to 1, right? How about s? Yeah. So negative 5s equal to 4as plus bs. That's it, right? Okay, but then a equal to 1. So a equal to 1. So it's a 4. And b equal to negative 9. Yeah. Hold on 1 second. So negative 5 equal to 4, 1 plus b equal to negative 9. Yeah? Okay. Constant term. Let me do one more page. Constant term. So constant term, let's see. 7. 7 equal to 4a 2b plus c. Yeah? 4a plus 2b plus c. Okay, so we know that 7 equal to 4, a1 plus 2b, b equal to negative 9. And plus c. What's the c? Can you calculate? 21. Yeah. So we have a 7 equal to 4 minus 18. So 7 equal to negative 14 plus c, right? So add 14, 21. Make sense? Okay. All right. So we have everything. Let me bring this one here. Wah! Sorry. Copy. We have, yeah. Okay. So A, 1. B, negative 9. C, 21. Okay. Now we want to find the inverse of that, right? Okay. So inverse of the notation F 1 over S plus 2 plus and inverse negative 9 over S plus 2 squared plus inverse of 21 over S plus 2 to the third power, right? Okay, now can you see that the table? Can you find? All right. So I have here. The first one looks like this one, right? So first one looks like that. And then third one looks like that. And then what else? It's the same. Okay. Take a look. Do you agree? Yes? Okay. Oops. Okay, so let me make a little bit here. There will be, we have a subtraction s minus -2. So a in that case is -2 then, right? How about here? A equal to also s minus -2. So a in that case -2 as well. Wow. What about n in that case? N equal to 1? Because 1 plus 1 equal to 2, right? Okay, now how about this? Aha, we need to take out the constant so that you don't get confused, right? Okay, let's do that first. So there will be inverse 1 over s plus 2 plus -9 inverse 1 over s plus 2 squared. Now you understand n equal to 1? Yeah. Plus 21 inverse 1 over s plus 2 to the third power, right? Okay. Now, let's finish it 2 terms and then let's talk about the third term. So we will get there will be 1 over s minus we don't want to go going back, right? So there will be e to the at, right? So e to the a in that case -2t and -9 constant and t to the n equal to 1. So just right there. And e to the at a equal to -2t. Make sense? Okay, now uh third one. So we take out, right? We take out the 21, but then if we are using this form, we have to have n equal to 2, right? So in that case, let me using different color. So this one also s minus 2, right? So a equal to -2. What about n? N equal to 2 as well. Yeah, not 2 as well. N equal to 2, right? So 2 minus 1 equal to 3. That's why power, the exponent is 3. Okay, then what about the 2 factorial? We have to have that, right? So n equal to 2. So 2 factorial, which is 2, isn't it? Okay, so let us using that times 2 over 2. So we will get plus 20 over 2. And we can use a t to the n. T to the n equal to 2. E to the a, which is -2. T. Whew. Is it good? All right. So we done for this section. I will see you in the next section. Thank you for watching. Bye.